All right, so today we're going to be working on our fourth lesson in assignment number 6, or in unit number 6, which is on assessing normality. So we've talked about variables that are normally distributed, and we standardize those by finding their z-scores, and how we could take their probability distribution and put it on a histogram to see a normal curve. We talked about the area under that normal curve, and we know how to find the area of the area under that normal curve by using our calculator. We can even go in the reverse order and find the z-score associated with a certain area under a curve to find like percentiles. And so we can convert those between those things, but then how do we know if something that we collect is normal? How do we assess to see if something is really normally distributed? So if we take people's heights, like in our class, are we normally distributed? Are our IQs normally distributed? And so today we're going to be answering those questions. That's assessing normality. And we do that with what is called a normal probability plot. And so you can do a normal probability plot by hand, or you can do it on your calculator. And we're going to do a lot of this on our calculator today. So let's take a look at some key facts that we're going to need to remember when we're doing a normal probability plot. To assess the normality of a variable using a sample data, you're going to construct a normal probability plot. Let me move this over. A normal probability plot. And so we're going to go through this process today. And if it's linear, then that's going to tell, oops. If it's linear, that's going to tell you that it's going to be normally distributed. And so that's what the first bullet point says. If it's not linear, then it's probably not that normal. And so we're going to look to see if the normal probability plot is linear or not. I want you to take a look at this table. And probably the easiest way to look at this is this: if I have 5 numbers and I select a sample of people, and in that sample I have 5 people, and I ask them how much time do they spend doing homework, and I normalized it, the z-score should look something like this. So we're going to have a z-score right in the middle, okay, and then I'm going to have something to the left or something below the average, which would have a z-score of about -0.5 and -1.18. And then those would match the z-scores to the right. That's if it's pretty much normally distributed. And so this is if there are 5 terms. Let's say you ask 10 people. So if you ask 10 people, the z-scores should look something like this if they're normal. And so if we were doing this by hand, we would take all of our observations of like the amount of time people do their homework and put that on the x-axis. Okay, so that might be amount of time on their homework. The y-axis would be the z-scores. And if this comes out to be linear, okay, which means that the amount of time doing homework matches the z-scores in a linear fashion, then it's normal. If it's not linear, then it's not normal. And so or the more linear it is, we should say, the more normal it is. Let me show you what I mean with this by taking a look at this table here. So we have this table, and I want to adjust the screen so you can see the whole thing. But if we ask for people's income, adjusted gross income, that would be like maybe in thousands. So like one person makes $7,800 a year. So that would maybe be somebody who's also going to college. They're not going to make that much. But we asked just random adults, 18 years and older, what their income was. This person, the highest person, would make $93,100. So we're just going to see if this is normal. Is it normally distributed? These would be our normal scores. So if it is normally distributed, we would have a z-score that would look something like this. And I'm going to do this on my calculator. So I'm going to pull up my calculator here, and I'd like for you to do this on your calculator as well. We're going to do a normal probability plot on our calculator instead of by hand. And so we're going to start doing this by going to, I'm going to turn this on first, by going to stat, and edit and edit. So I'm going to press enter. And I've already put these values in my calculator. So you can see list 1, I have 7.8, and then 9.7, 10.6, and so on. I put those in list 1. And then I also put the normal scores in list 2. Now you don't have to do the normal scores. I did the normal scores so you can see whether or not it's linear. And so what we're going to do next is, right now if I press y equals, I have nothing on, nothing to graph. And so once you put those values in, again, you put those values in by going to stat and edit, edit. And we're going to use our stat plot to make a normal probability plot. So I'm going to go to second and y equals, and you can see right now the stat plots are all off. So what I'm going to do is turn the first one on. So I'm going to press enter, and you can see right now it's off. So I'm going to, my cursor's on, and so now I'm going to turn it on. I'm going to scroll down. The very last type of graph that you have over here is a normal probability plot. And so I'm going to move my cursor over that normal probability plot and press enter. And as soon as I do that, I can do a normal probability plot for list 1. And I'm just going to call it X data, and I'm going to use, maybe I'll use my plus signs to represent this data. Okay, so I'm going to use plus signs there. And instead of list 1, I think what I'm going to show you first is what it would look like if we did list 2. So I'm going to change this list 1 to list 2 by going second and list 2, which is right here, the L2. So what it's going to do right now is make a normal probability plot of these values. So if I were to press graph right now, it wouldn't show up a whole lot because you can't really see that very well. But we could zoom, and if you press zoom and go down to zoom stat, which is number 9, and press enter, then it'll make the window the best possible window to see all of those points. So here's what this means. This is kind of like normally on the x-axis and normal on the y-axis. In other words, it's all symmetrical. It makes a straight line. So if I were just thinking about this, if all of these like squished over here to the x-axis, I would have a lot of points in the middle, and I'd have some to the right and some to the left. And if I looked at the y-axis, it would be normally distributed about the y-axis too. In other words, here's where y is 0, and I have some with z-scores above and some with z-scores below. And so that's a normal distribution. This is perfectly normal. You can see it makes a perfect straight line. Okay, but let's take and see what happens if we do a normal probability plot, not for list 2, but list 1. So let's go back to our calculator. I'm going to go back to second y equals, and I'm going to use the same plot. It's on. I'm going to press enter, and now I'm going to change it. I already have it so that it is a normal probability plot, which is my last option, except instead of list 2, I'm going to use list 1. So I'm going to change that to list 1, and now I'm going to press graph. And I'm going to have to redo my window, so I'm going to go to zoom. I'm going to go down to number 9, so zoom stat. I want you to look at those. This is not really that normal. If it was normal, it would make a straight line. And you can see there are a lot more values over here than there are over here. Okay? And so this is not really normally distributed. And you can kind of tell that it's not because, man, about half of our data is like less than 20. And then we go from 20 to 30 to 40 to 50 to 80 to 90. So it's really gets spread out here at the end. It's not really symmetrical. If it was normally distributed, it would be symmetrical around the middle. Like if the middle here is, if the median is about 20, 7 is about 13 away from 20, but 93 is like 73 away from 20. So it's not really that normal. we would want to make sure that something is normal. Here we only have 12 data plots. They say the more data plots that you have, the more you can determine whether or not something's really normal or not. And they say that you can pretty much guarantee that something is normal if you get 30 data points. So in other words, if we were in class right now, let me show you what the next slide would look like. If we were in class right now, we would be working on something like this. Well, here's the normal probability plot, and this is what you just did on your calculator. And you can see it's not really that normal, okay? But if we were to be in class, we would collect data on something. It might be our heights. It might be our weight. And there are only, let's say there's only 15 of us in class, we would check to see if we are normal in that variable. So we would check to see if our height is normally distributed or our weight is normally distributed. Okay, we could check our GPAs and see if that's normally distributed. If we were doing a project in class, and in a normal year we would do a project in class where you would have to gather data, and we would want you to collect 30 data points on anything that you wanted. It could be screen time on your phones. It could be amount of time you spend doing homework. It could be the amount of money you get paid at a part-time job that you have, to see what the distribution is of that. And if you can collect 30 data points, then you can do a normal probability plot to see if that variable is normal. And you can do that on your calculator. That's what assignment 4 is all about. And next time we'll work on assignment number 5, which is normal approximation to the binomial distribution. So that'll be next time. Good luck on your homework today. We will go over questions that you have when we meet up again. Good luck, everybody.